Hi everyone, welcome to BMEN 207, Computing for Biomedical Engineers. Hi, I'm Professor John Hanks, and I'll be your instructor for this class this summer for the next 10 weeks. I'm looking forward to getting to know you and then also teaching this class. So I hope all of you have watched the welcome video that gave a little bit of background about the class. For this lecture, what I'd like to do is just go over the syllabus, tell you a little bit about the assignments and the projects, and really set your expectations for the class. So let's get going. First off, I'd just like to introduce myself. I'm not a typical academic. I've come from industry. I was at a company for 24 years, and that company started out with a few employees, and we grew to 7,500 employees. And then I was at a semiconductor company and worked for 4 years there. And all through my career, I've done software and worked on both software and hardware projects. I've done software for fun, and I had a couple of Android applications in the top 10 at one time, and had a lot of users. And over my career, I've learned 9 or 10 different programming languages. And what I hope to convey in this class is a method for learning a new programming language, because you'll probably know or learn several of them over your career. I do have degrees both in Texas A&M and the University of Texas. I live in College Station and Austin, and I travel back and forth quite often. So philosophically, I really like the combination of technical and communication skills and value that. So in communicating with you, I hope to have very high standards in communicating, and from you to me as well. So I've done a lot of things in my career, from starting companies and just the other things that I like to do is I enjoy sports. I have both of my children were athletes and also computer scientists and engineers. I read a lot and enjoy my favorite Netflix, Amazon shows. The one that I'm kind of hooked on right now is 30 Rock, which is just my favorite comedy, and Ozark. So I hope to learn about you during the semester, but here's a little background about me. Let's kind of dig into what we're going to learn this semester. Wanted to start off by saying that I believe the 21st century is all about algorithms. And at the core of that is learning about programming and learning about how to collect data from sensors and how to analyze data. And you hear a lot of big words, trendy words like data science and big data. These things have been around for some time now, but really the computation power and the availability of easy to use software tools is just really coming together now. And having access to the ability to create programs, and then also the accessibility to data, makes this an exciting time to live in. Let me give you a few examples of that. We're all living in the period of COVID-19. We'll probably remember the rest of our lives, 2020, the spring and the summer, as being the summer of COVID-19. You guys have all seen the reports from Johns Hopkins about the location and tracking the coronavirus, so that you know that the tools that Johns Hopkins used was Python. They used Python to create the information to be able to show geospatial information where the locations of the virus were located, as well as to use the tool to aggregate data from several thousand sources, either through application programming interfaces, APIs, and we will learn this in the course, how to tap into an API endpoint, collect the data from that web service location, retrieve it, and analyze it. Interfacing to different databases, and even scraping. Web scraping is a common thing that's done with Python and web-based tools. It's called scrape a website, collect the data from that website, pull the information that's needed, they reference it, and then put it into their information. So a lot of disaggregated data was gathered in a meaningful way to be able to track the virus. So that's an example. And of course, modeling and simulation of the spread of the virus with Python was used as the algorithm tool as well. So one that you may not realize also is that the tools that were used to influence a past election, or potentially influence an election, I'm not sure of that, but it's reported that Cambridge Analytica used Facebook data. They scraped the data from 87 million Facebook accounts, and they developed algorithms that really correlated Facebook feature set with personality tests, and they used surveys to do the personality test, and really were looking to try to find out how to predict somebody's political orientation and if they could be politically influenced by the combination of what was on their web page, their Facebook page, and their psychological profile. And they basically, the personality modes were 5 different areas, and from that information then they could tell what type of ads to present to you, subtle messaging, so that they could influence you. And really that's what they were looking for, people that could be influenced with Facebook ads. How they did that, they looked at likes and really had 300 million features, 250 algorithms that predicted behavior for each user. And they made this offer to both the Republicans and the Democrats. So it wasn't like they were trying to have one party win over the other. I think they, from what I've read, is they offered it to the Democrats and then the Republicans, and the Republicans in this case took advantage of it. So, and ultimately the goal was to deliver these subtle messages that was the right language that would communicate with your personality type to influence you. So these are the things that we have to understand that exist in the world today, and be aware that algorithms, data can influence us. Another application, or something else to talk about here, is how was Python used? Well, web scraping, the text analytics, something called natural language processing or programming, NLP, and in Python there's libraries to do that. Surveys potentially built with Python, and then definitely managing large sets of data was done in Python, and then finally machine learning and the predictive algorithms to be able to pull this off. All are capabilities in with Python. Final thing here is another application area, just to give you a broad sense of what can be done with Python, is quantitative finance. There's a website called Quantopian. It's a trading environment with more than 300,000 users. It's an open environment, and you can trade stocks, commodities, and other things, and create an algorithm based on past historical data. And it's trading, they have an algorithm, you develop an algorithm, back test it versus the data, submit it to the website, and then you track it over time. And they've paid out more than $50 million to date and licensed these algorithms from their community. So this is really kind of this thought of how to use big data and how to use a community to be able to create some new intellectual property that could have value. And I think in the future we may see more and more of this, and you can see that Apple and Fitbit are trying to aggregate data. Then the question becomes, will they open that up to the community? And in some ways they've started to do that, so that biomedical engineers, computer scientists, Python developers can all add value to the data that they've collected. There's some challenges in our industry in that we have privacy and FDA regulations, but from a perspective of what can be done with Python and what can be done with data, these are a few examples that I quickly came up with. So what I hope to convey in this 10-week course is not just Python or just LabVIEW, but to learn how to learn a new programming language. And to do that, I think you need to be inspired by what you can do with software and data analytics, to really develop in your mind an interesting application and be in pursuit of trying to solve that application. So I have a survey that's on eCampus, and please take that survey. And one of my questions is, what application would you like to solve? Because I believe you learn the best if you find something that you're really interested in. So I'm interested in your answers there. And by the way, this initial survey is a quick assessment to see the skills in the class and then to learn a little bit about you. So I hope that you answer that. It's not to be graded, but it's something I'd be very interested in seeing from you. The other thing is, I really tried to pick some tools for this class that are high level enough, and some of the best tools in the industry, both the Spider IDE and Python and LabVIEW, are all things that we're going to use to be efficient programmers and application developers. I don't want to go down to the lowest level and spend a lot of time on details. I want for us to come up to speed quickly and then work on applications, and that's the goal of the class. But we need to learn these fundamental building blocks, and then once you learn how to learn those things, I think you can take your knowledge and take it to multiple languages. And we'll actually learn 2 languages in this class. At a minimum, you'll be introduced, and then you can learn these languages over time. So I really do believe to be able to become a programmer that you have to really program every day, and I call that hack a day. Have you done some kind of programming logic problem today to be able to be good at being a software developer or algorithm developer? So I encourage you every day this semester to do something with BMEN 207. Try to develop a habit of actually, over time it would maybe something that you enjoy, and develop a habit of being able to program every day and solve problems. So what you will learn in this 10 weeks is really to solve problems, develop algorithms using constructs of a programming language, such as for loops and conditionals, functions and arrays. I'm also going to show you how to time your algorithm so you can look at improving performance, look at different data types into how to construct an efficient program, learn how to read files, manage large data sets, slice these large data sets, also do some numerical operations, statistics, curve fitting, linear equations, and you'll see in a minute that we have an imaging application as one of our projects. And then at the end of the course, we'll do majority of the course, about 7 weeks on Python, and then we'll introduce LabVIEW, and then be able to quickly come up to speed on LabVIEW once we understand the fundamentals of programming. So why Python? Bottom line, I think it's really an abstracted language. It's very easy to use. You don't have to put a semicolon at the end of the line. You use indentation and white space to show the block constructs of the code that you're working on. So indentation and white space is syntax within the language. There is a large collection of libraries. Python's been around about 25 to 30 years. People have been working on it and adding content through open source. So there's very popular tools such as NumPy, Matplotlib, and Pandas that really allow you to work with numerical data, NumPy, NumericalPy, Matplotlib, which is for plotting and graphing. Very similar. It's just very similar to the syntax of MATLAB, and then Pandas is working with large data sets and a data type called data frames and series. A little programming concept here. It's dynamically typed, so you don't have to define each of the data types, integer versus float. It will take care of that and understand that for you. It makes programming much faster. Very abstracted, so that with high-level function calls, you can do a lot of large tasks. And then once again, there's a large community of developers that are writing Python code. You can search on any error code, at least anyone that I've come up with, and see somebody out there has written something on what the error code means and gives you a suggestion for help. And Stack Overflow is really the source that I typically go to online for errors with my code, and I'll point you to them here in a minute. So later in the semester, we'll cover LabVIEW as well. I work for the company that developed LabVIEW. I worked closely on LabVIEW. At one time, led the team that developed the algorithms for signal processing and image processing. So LabVIEW is a really good tool, really great tool, has a lot of functionality, but I think its main benefit is the connection between the language and the hardware is really tight, so that you can do real-time input-output, real-time measurements with LabVIEW. I do believe developing a user interface in LabVIEW is easier than Python, and that's another attribute. For example, SpaceX, when they launched their rockets, their control system is built out of LabVIEW. The user interface is LabVIEW to be able to control the launch. And then there's a large community of professionals that are using LabVIEW as well. And then you can, they have capabilities of taking LabVIEW and programming field programmable gate arrays, which is a hardware, so you can implement LabVIEW into a hardware logic array. So those tools we'll cover this semester, and at the high level, I think how you can make an A in this class, and I used flowchart diagram, a pseudocode here to explain this, and we'll cover pseudocode and flowcharts in more detail. But when you start a new concept, I've developed videos that you can follow along with. So you can watch the video, and I'll be coding in the video, and then you can code. You can see my errors. You can make the errors. We can quickly get through those and see how to solve the problems and learn the syntax and learn the concepts. Once you're finished with that, I've referenced several online tutorials and references such as W3 Schools. They have a nice environment for learning a concept, and you can interact with the web itself to do coding and to check that you understand the concept before you move to the next concept. So, and then I have built some assignments that are in source code. So you'll get a Python source code from eCampus. You'll download that, and I'll have a template source code with questions within the source code, and it's in the comments. And I'll talk a little bit more about that later today in this session. I think you should do this 3 to 5 times a week to keep pace. We're going to move very quickly. And if you have questions, yes, I'm going to have what I'm calling a Zoom class hangout. You can meet with other students, check for clarity, help each other, and then you can also come to my office hours. And if you're not, you can go on to your next video. I fully suspect many of you may have had a lot of experience with Python already, and you'll be able to go through these things very quickly to get to the next lecture, the next section of the class. So I believe that to really learn how to code well, you must code, and you must do it often. It's like learning a new speaking language, like English or Spanish or a second language. You have to do it, and you have to be immersed in it. So I've developed the videos, and all of these videos are fairly short. Some of them are as short as 5 minutes, and the longest one is maybe 25 to 30 minutes. I think the working with strings is the longest one. And then you'll get code template that you can then develop the code in. And so you'll code along with me. So that's the idea, the methodology for learning in this class. Once again, I'll have what I'm calling a Zoom class hangout. You can come to this location here on Zoom, Fridays at 11, and ask other students for clarity assignments and collaboration, time for collaborate. And if you want to set up an office hour meeting with me, or just come to the office hour, I'll be hanging out at those times, Tuesday and Thursday at 11 a.m. also, so that you can ask questions. So for the assignments and projects, pretty straightforward. The short assignments, like I just described, where you'll get the source code and you'll answer questions within the Python code itself and then submit that code back to me, or you'll take a quiz online that I'll send to you, and I'll give you instructions such as screen capture the results and submit that. We'll probably have about 20 assignments this semester, 15 to 20 assignments this semester, and then we'll have a midterm exam, which will be 20% of your grade. And then there'll be 2 projects, which will be 20% each. I'm going to talk about each of those in just 1 minute, and then we'll have a final exam. So for your assignments, the assignments basically are meant for you to understand the concepts. And so if you don't submit the assignment back to me, of course that's a 0. If you get all the answers correct, that's a 1, and if you have any incorrect answers, it's going to be a 0.5. So very simple grading system, and each assignment's about 1% of your grade. So I would hope that you would take time to work on that. And I may have some assignments, I have a few of them that are more than 1 point. They take a little bit more time and effort from you, so they'll be counted more than 1 point. So the assignments often will be, the questions will be in code. So here's an example of this. So I've got an introduction, I tell you what the objectives are, and then you perform the coding task or answer the questions within the code. So for example, here's what's your name, and then basically I've used 2 greater than signs and then JH, and then wrote the answer. And then if I ask you to do something like print out something, you can just ask the question, print Texas Aggies, and then you'll write the code below that. And so you'll see that there's a number of questions here, and then you'll just answer below each of these comments. So these are comments in the code. You'll learn that this # means don't run that code, and you can use that to comment and outline your code. So that's what I'd like for you to do when you work on your assignments and turn them in, is answer the code and then submit the source code back to me. For grading policies, the grading policies are your, once again, homework, short assignments are 20% of the total grade, midterm, 2 projects, and then a final. So for the projects, I've got a couple of real-world applications here I think that are very good. I've worked in the past in the commercial world on a project to put wearable sensors on cattle, and I have a lot of that data, and what we'll be doing is looking at cattle that have an optical sensor to measure the heart rate. And we also have it's on an ear tag on these cattle, an accelerometer, so we can measure the heart rate and if there's motion. And the exercise will actually look at the magnitude of the accelerometer to understand when the cow has stopped moving and when to analyze the data for the heart rate. So it'll be project 1. I have days of data there, so you have a large data set that you will work with and be able to analyze the movement of the animal as well as their heart rate. The second project is going to be a project that looks at is this a mole or is it a melanoma? And there's a classic method called ABCD, quantify the symmetry or asymmetry of the lesion, quantify if the border is fragmented, and then quantify the color. And we can do that very quickly within Python. I have sample images for you to work on, and this will be an introduction to image processing and how to quickly identify if there's melanoma or a mole in the image. So those would be the projects for the semester. I'd like to point out to you there's a wealth and plethora of online tools for learning Python and LabVIEW, and some of my favorites here I've listed out. We will use w3schools.com for really as an extension to our class. I'll do the videos, you follow along with that, and then you can go to W3 Schools to extend your knowledge, refresh your knowledge, ensure that you understand the concepts. And then Stack Overflow is the source that I typically go to for error codes. So you can copy an error code from the Python console right into your Google search and then it'll take you often to Stack Overflow, where somebody has answered the question that the error code that you've copied into Google. In addition, there are other video sources, and I like Corey Schaefer. I've really modeled the videos that I've done after Corey Schaefer, but with a biomedical slant to them. So that's the idea there. Corey's probably got 100 different videos on Python and other programming techniques online, and so he's a very good resource as well. So my contact information, here's my email, and then my Zoom address for the office hours as well as the class hangout. I'm looking forward to getting to know each of you, and I hope that you can make a calendar meeting with me. And I'll give precedence or priority to those who send me a calendar invite for the office hours, or you can just show up and I'll have an open door policy where you can just ask any question that you want. So there is an assignment to get us started. So I do have this background survey, an assessment survey that I'll send you. I've got some questions, some Python questions in there. I'd like to know the skills that you already have. But it's not tested, and it's not a personality test either. So, and then I have a short question answer about an application that you would like to solve with programming. So feel free to write in something that you think is an interesting project there. Please review the syllabus. We do need to ensure that you have all the right software on your computer. I'll be directing you to Anaconda, to install Anaconda, which includes both Python, many of the analytical modules, numerical pi, scipy, and all the modules that we'll be using, as well as the integrated development environment, the IDE, Spider, that we'll be using. So you should be able to install that very easily. It installs down onto your computer, and then you open it and install it, and it works very well on Mac and Windows. And so, but if you have any issues, have any problems, please reach out to me and I could help you troubleshoot installation of that. And then I have an intro to the Spider IDE video. I'd like you to watch that as well. The assignments will be given on eCampus. You'll have to go there for the rest of the assignments, and I'll send you a notification by email to keep you moving along through the course. So I'd like to also deliver the message, don't get frustrated. I know that we're trying to make the best of this through this online class, and many of you may have preferred to take the class at A&M itself, but I'm glad that you're taking it online. I'll help you through this, and we'll learn a lot together, and let's try to make it through this, and I think we'll have a good summer. So I'm not here to frustrate you. I really, truly want to inspire you to learn how to program and enjoy programming and be really good at it. Please ask for help. I do have some lessons about how to ask for help or some advice. If you're sending me an email, explain the problem or your confusion, do it in a couple of sentences. Tell me one or the two or the couple of things that you've tried, and then if you have an error code or an output that's an error, please copy that in there and send it to me. And so that'll help us move quickly through any questions. So my final message is GPO, grit pays off, and I think we're going to have grit this summer and we'll make it through, and I'm looking forward to it. All right, thank you.